Well, good morning, everyone. Hope everyone is enjoying spring so far, even though it's still pretty chilly up here in Boston. I wanted to thank everyone for taking the time out of their morning to follow along. For those of you who don't know me, my name is Chris Glover, and I support the aftermarket sales here at Airxchange. And for about the next half hour or so, I'm going to be discussing preventative maintenance and cleaning of energy recovery devices. So we had a pretty diverse group of people sign up, so I tried to create a presentation that could appeal to a wide audience. Some of this may be completely new to you, and for some, this may be a refresher. However, regardless of your background, I'm hoping to touch upon multiple areas of interest. One of the topics I like to discuss routinely is preventative maintenance. It's because it's one of those topics where I feel the perception doesn't adequately match the reality of the situation. On the agenda today, I'll discuss briefly the operating process. We'll discuss why preventative maintenance is important with these devices. I'll go over the typical preventative maintenance process. We'll view several videos of cleaning methods, and then I'll end the demonstration by showing you some resources that are available to you. I'd like to point out that at any point during this presentation, feel free to use that little chat box to enter questions. I'll take note of them and try to answer as many as I can at the end of the presentation. So energy recovery in its basic form is merely an air-to-air heat exchanger. It's used to recycle a large portion of the energy in the exhaust air, and it uses it to condition the incoming ventilation air. So looking at a typical system, the outside air comes into the unit and is heated or cooled by the primary conditioning element to a point that is suitable to be delivered to the space. The outdoor air dilutes the space air with fresh air, and the stale air is then exhausted back through the unit. The exhaust air contains energy that can be used to perform work prior to it being lost to atmosphere. Now let's look at that same process, but adding an energy recovery wheel to the system. Instead of the primary conditioning element having to treat the entire ventilation load, the energy in the exhausted air performs a large portion of the work, which significantly reduces the capacity required by the heating or the cooling element. I often refer to this process as a load shift, where you're shifting the air conditioning load over from a high-grade energy source to a low-grade energy source and still accomplishing the proper ventilation to the space. So why is preventative maintenance of energy recovery devices important? Well, first and foremost, it takes a significant amount of energy to condition outside air. Looking at some localized energy models for representative cities, as you increase the amount of outside air, it's going to have a major impact on how much energy is required to condition that air. On average, an energy recovery device is about 4 to 6 times more efficient at conditioning outside air than your typical primary heating and cooling element. So even small amounts of performance degradation could have a substantial impact on the way the building operates. And it's not all localized to energy use. Performance degradation would have an impact on occupant comfort as well. An energy recovery device is an integral part of the HVAC system's ability to control humidity. And as we all know, humidity plays a major role in how we as humans perceive comfort. So an improperly operating energy recovery device plays a very large role in a building's overall energy use and how it conditions the air for occupant comfort. So what causes a wheel to not perform properly? Well, the number one culprit is whether the device is clean or not. Now, keep in mind, we're going to be discussing and showing you or demonstrate what an actual dirty wheel looks like. The second most common item is leaky systems, such as worn seals or stuck dampers. The third would be improper rotation. Now, this could be due to incorrect control algorithms, loose or failed belts, or failed motors. And keep in mind that if a wheel isn't spinning, you're getting essentially zero performance out of the device. So before we look at typical performance degradation curves in systems, you may be asking yourself, I've been told plenty times before that wheels are self-cleaning. And yes, that is true. but only for dry dust and particulates. And that's because the wheel is rotating between two opposing airstreams and it's constantly exposed to high velocities blowing in either direction, coupled with the fact that the airflow is laminar in nature and not turbulent like a coil. A quick fun fact for you is that most wheels have a 70% open face area, meaning if the particulate is small enough, it will be blown directly through the media, and if it's large enough, it will get sucked to the face and blown off when it enters the opposite airstream. So how do these devices actually get dirty? Well, it's the gaseous components in the airstream, TARs, smokes, VOCs, things that I like to refer to as sticky stuff. That will eventually get deposited on the wheel, and once you have anything sticky on the wheel, now the particulates can actually have a surface to stick to. So if an energy recovery component gets dirty, what's its relative impact on performance? In most modern buildings, you're going to have a gradual linear degradation that happens over time. Looking at the charts, you'll see three lines. The top blue line represents the device's ability to transfer heat. The bottom red line is the device's ability to transfer water vapor. And the middle line is the cumulative ability. As you can see from these curves, the device's ability to transfer water vapor decreases at a quicker rate than its ability to transfer heat. So as the device gets dirty over time, the first thing you're going to notice is that you aren't transferring as much water vapor. And in most buildings and in most cases, humidity is a big concern. Another thing to take into consideration as a device gets dirty is it starts to block some of the airflow, which not only places a burden on trying to deliver the code required ventilation, but also places a structural burden on the component due to the higher pressure drop. The higher pressure drop will then result in greater fan energy use. So you can see how we're building a case where all these components are interrelated. Now looking at these profiles, you can see that they're very distinct from one another. How can you determine what the rate of degradation is going to be for your space? Now this is a pretty tricky question because the answer depends on the type of building and where it is. Generally speaking, the more rural the building with relatively clean indoor air, like office spaces or K through 12 schools, tend to be on the left side. The more urban the environment and the dirtier their indoor air, like casinos or dorms or restaurants, tend to be on the right side. So to assist folks and give them a relative idea of what the potential rate of degradation will be, we have developed this chart, which is included in our operations and maintenance manual. It's based primarily on the ASHRAE classifications of air. The majority of building spaces are going to be subject to class 1 and 2 air. This would equate to a low to moderate rate of degradation. And as you move over to a class 3, the rate of degradation is going to increase. And for class 4 air, where wheels aren't typically employed, you shouldn't have to be concerned with that particular class. So now that we have a basic understanding of why the performance of these devices is so important, let's discuss some procedures to keep them performing at their optimal level. So one item in particular that always has been a technological barrier to energy recovery is the perception that it requires a tremendous amount of maintenance. In my experience of working with these devices, and that's over 13 years now here at Airxchange, it's not so much the maintenance that they need, but more routine observation. And observation can go a long way in regards to extending the life and optimizing the performance of these devices. The best preventative maintenance procedures start off with developing a routine schedule and sticking to that schedule. And keep in mind that not to over-maintain these devices, because over-maintaining adds little to no value to the system. However, as we all know, a little preventative work can save you quite a bit on more costly service repairs. So bringing back this chart, the first part to developing a routine and schedule is to gauge what class of air the device is subject to. In most cases, go with your gut on what you feel your building space requires. Once you assign yourself a class of air, you would then refer to the suggested visual inspection interval. Most building types are going to fall into Class 1 and Class 2 air. For those classes of air, we recommend an annual inspection on these devices. For Class 3 air, we recommend an inspection every 6 months. As you get more familiar with the device, you can further modify the schedule to best suit your building type. I would also suggest performing this inspection during the shoulder seasons where the conditioning load from the ventilation isn't at its peak or too severe. So what should be included in a visual inspection? In our operation and maintenance manual, we have developed this checklist to simplify the process and suggest the items you should verify. The total inspection per wheel should take about 15 minutes. You want to make sure that there's no damage to the segments, that the energy transfer is not excessively dirty or covered with tacky substances. You want to make sure that the belt is installed around the wheel and pulley. Make sure that the belt is positioned and tracking properly. Make sure that the belt is not flipped or twisted. Make sure that the belt is not excessively worn. You want to spin the wheel freely by hand and make sure that there's no binding occurring. When the motor is running, make sure that it's operating at or below full load amps as indicated by the motor nameplate. Make sure that the wheel is turning in the proper rotation. You want to check the diameter seals and make sure that they're set properly. You want to make sure that the media segments are installed in the wheel and sitting flat, and make sure that all the segment retaining latches are closed and secure. Now, some of these items may seem trivial or self-explanatory, but they can be overlooked during the process, and in doing so you may miss an item that could impact the device's ability to work properly. The most common service and maintenance items are discussed in our operation and maintenance manual in great detail, but the one I wanted to focus on during this discussion is cleaning. Okay, so before we dive right into the cleaning process, I wanted to put a brief disclaimer here. Just because you're performing an inspection once or twice a year doesn't necessarily mean you're going to be cleaning the devices at the same rate. You only need to clean the segments as required by the application. So in other words, if they're not dirty, there really isn't any added benefit to cleaning them more often than required. So one of the questions you may be asking yourself is, well, how can I tell if a wheel is dirty? Well, usually there's going to be either a visible layer of dust on the heat exchanger, or it may feel somewhat sticky or tacky to the touch. If that's the case, then we're going to discover the steps on how to clean it. So on our website, we have numerous videos that are available to you that provide instruction on how to perform maintenance and common service repairs on the energy recovery devices. I trimmed one of those videos to demonstrate the segment removal process, which is really the first step to the cleaning process. And I'm going to play that video for you now.
You'll need to open the two adjacent latches in order to remove the segment. Latches are located along the inside of the rim wheel at the end of each spoke. Use a small flat bar or screwdriver to first release the latch. Then swing the latch open. Remove the segment, the outer edge first. Be sure to close both latches completely before removing the next segment. Important, removing the segment will cause the wheel to become out of balance. Remove the opposing segment. Start by opening the two adjacent latches that hold the segment that's 180 degrees from the first segment removed. Once removed, the wheel will be balanced again. Continue removing remaining segments. Be sure to keep the wheel balanced. Be sure to close all latches before moving to the next segment.
Great. So one of the unique features to the Airxchange design is that the energy transfer segments are fully self-supporting. So you can perform this process as many times as you like, and you don't have to run the risk of damaging the structural integrity of the device itself. Once the segment's removed, there's really two ways you can approach cleaning the segment. The first method is the dry method using a coarse brush and a vacuum. This works best for light dust that is accumulated from operating in relatively clean environments. Now I'm going to play a quick video demonstrating that process. For segments that have a light layer of dust on the face of the wheel, a dry method of cleaning may be used. Using a coarse brush and a vacuum, lightly brush the face of the segment while following along with the vacuum. Once the process is complete, flip the segment over and repeat the process for the opposite side. Once both sides are clean, check to make sure that there's no sticky residue left on the face of the wheel. If all clean, place aside and repeat process for the rest of the segment. So the second way to clean a segment, and in my opinion the most thorough way to clean it, is to use a soapy solution. I want to stress that using the vacuum method will remove the dust, but what it won't do is unclog the desiccant pores that are responsible for the vapor transfer function of the device, some of which may not be visible to the eye. By soaking the segments in a watery soapy solution, you're allowing the degreasing agent to thoroughly clean not only the face of the wheel, but all the way through the media as well. Now, I could show you one of our videos, but what I thought would be more interesting is to show you a third-party video that I found online. It just goes to demonstrate that the cleaning process can be accomplished in a minimal amount of time and effort, and that's demonstrated by someone other than Airxchange. So I'm going to start the video. For a solution, we recommend using either a non-acid-based coil cleaner, like an evap cleaner in a 5% solution, or any common detergent or degreaser like Dawn or Fantastic. I've also come across some pretty ingenious ways to make a tub. I've seen lumber in a makeshift box with a plastic drop cloth over it, like a small version of a backyard hockey rink. I've seen common tubs like the one in the video, the ones that you pick up at Home Depot. And for larger segments, I've seen people that have had really good luck with kiddie pools. It's really up to you and what you feel is the easiest way to submerge the segments. Now, the longer you let the segments soak, the better the clean, but that is really going to be site specific. One of the items that's very unique to Airxchange is our desiccant is held onto the media by a mechanical bond. Therefore, no matter how many times you wash the individual segments, the desiccant will never degrade or come off. And an often overlooked benefit of cleaning the energy recovery wheels this way is that it's a more hygienic and safer approach than cleaning in place, which introduces a lot of water to the cabinet or potentially dislodges debris and pushes it further downstream. Now, after shaking the majority of the water out of the segments, they really don't have to sit for that long. You can place them back into the unit, and as soon as that unit kicks on, the air is going to dry them out rather quickly. So preventative maintenance for Airxchange wheels is predominantly observation and cleaning. So what happens if during the checklist process you discover a service item like a failed motor or belt or missing seal? Unlike older monolithic wheels, Airxchange designs are modular in nature, so you only have to service what needs servicing. Each energy recovery wheel is given a unique serial number that is located on a nameplate that is right above the pulley. If you go to our website at airxchange.com and click on the aftermarket link, you will see an online parts lookup tool. Click on that link and then enter the serial number into the search box. And what that will do is will provide you a complete illustrated parts breakdown of that cassette. You would just select what parts you need and it will automatically populate an email that gets sent directly to us. Just a quick note, all service items are in stock and ready for either same or next day delivery. Okay, so that was quite a bit of information and I'm not expecting everyone to remember everything. So where can you go to find more? I would first start off at our website, airxchange.com. Here you'll find access to all our technical materials. Everything I've discussed is located here in even greater detail. If you are in charge of keeping these devices operating, I would suggest starting by downloading our operations and maintenance manual. The website also has all of our technical videos, which provide instruction on common and service and maintenance items. You'll also find catalogs, case studies, relevant industry information, and contact information to get in touch with us. Also on the website, you'll find access to our aftermarket products section, which contains information on our replacement wheel products. So if you come across any wheel that is inoperable, ours or otherwise, we have designs that were developed specifically to assist those who are in need of replacing these older wheels. And once you replace an older monolithic wheel with the Airxchange design, now you have the ability to effectively clean and maintain it. And lastly, if you need to get a hold of me, here's my contact information. On a personal note, I'm always interested in hearing feedback on my presentations as well as any ideas for future presentations. So feel free to send me an email with any items that you may have. I'd very much appreciate that. With that said, I wanted to thank you all for being here, and I'm going to take a minute to review the chat box and answer any questions you may have. Thanks again.